So this is the business end of my dual-copter, and I've had it posted for a couple of months now. It's a Contra rotating dual-copter, and I've had several people ask me about the motors I built here. They were made from two Hextronics DT750 motors, and so it's Contra rotating. I've got them linked together with the shaft from the bottom motor going through the middle of the top motor to get the Contra rotating effect. So I've decided to build another dual-copter, and I thought this time I'll document what I did with the construction of the motor parts, in case there's any more people that are interested in doing something like this for themselves. So looking down here, I've got the two motors. These are fairly inexpensive motors that I've pulled to pieces, DT750 motors I've pulled apart, and the here we're looking at the original shaft of each motor, and I've removed that. We won't be using that, and I've acquired this new 4mm stainless steel shaft that will be driving the propeller, the top propeller, from the bottom motor. So it'll be secured into this bell housing. And the critical thing really is to isolate the top motor from the bottom motor, so the shaft can go from the bottom motor, can go right through the top motor without being connected to it. So the tricky part was making this aluminum piece right here. I made it on a drill press using a lathe chuck that I could fit onto my drill press. If you had a lathe or milling machine, it would be a lot easier to make, but it's made from some round aluminum bar stock that I held in the chuck, and used a carbide cutter just to cut away this area here, and drilled a hole through the middle of it for the shaft, and had to enlarge the hole in the bell housing a little bit because we want to uncouple the shaft that sits pretty tight normally in these bell housings. So anyway, I drilled a little hole in the bottom, the same diameter as this hole, so that I could press fit this onto the bell housing, and enlarged the hole at the end a little bit to fit a ball bearing that will fit in like this. The other thing I did was I drilled some holes. When I pressed it on, I drilled some holes in here to keep the cooling holes, and also add some light, remove some weight from the aluminum piece here. So once it was pressed on, the next thing was to put a ball bearing in the bottom. So very carefully, required using the carbide bit. I put this in the chuck, spun it, and very carefully with the carbide bit just enlarged this hole big enough to press fit this ball bearing in here. So now we've been able to isolate. Normally this bell housing would be secured to the shaft, but I'm now able to isolate it from the shaft. So this bell housing will be turning in one direction, and the shaft for the rear motor, the bottom motor, will be turning in the opposite direction. So now they're isolated from each other. So the next step was to just drill some holes in here so I can secure the propeller on top of this bell housing. So I'm using one of these T-style propellers that I enlarged the hole here, and also drilled some holes in here to match, so it will fit on like that. Made a washer from the aluminum bar stock that I just cut off the hacksaw and kind of ground it down, ground it flat a little bit, and it will sit on here, and then it will be all bolted down as one unit. And this whole unit could be balanced in a prop balancer. So the next step was to trim the stators down a little bit on the edges here. Normally this would go up past the ball bearing on the stator, but I only need one ball bearing since these are going to be joined together. I didn't need two ball bearings up against each other, so they will join together like this. with the shaft for the bottom motor going right through. Well, I'd only need one engine mount once this is all together, so I was able to find some brass tubing that would fit over this quite nicely, and with quite a little bit of filing down of these areas here just to get it to fit nicely, and put a set screw that will go through the original mount for this motor and into the stator to house it and stop it from turning up with the rotor. I have pulled off the old windings and rewound them with solid wire as opposed to stranded wire that usually come with these motors. But I wanted to turn a much bigger propeller, so I've lowered the voltage constant down from 750 kV down to about 640. So I'll be able to spin these larger propellers without overloading the motors at all. I've set the new shaft into the bell housing of the rear motor, and I have a set screw, so I ground a flat spot on the new shaft and I've secured it down with a set screw. The propeller is bolted down onto the bell housing of the front motor there, and we've got it balanced nicely. And here I've mounted the motor mount onto a bracket, and we'll be able to insert the stators into both sides and screw them down with set screws here and a small screw there. So now we have the two stators mounted onto the motor, onto the test stand here. I'm going to insert the rear motor bell housing right through. Sliding on. So the front bell housing has the ball bearing there, and the stator of its motor has the motor has the bearing there. So we need to separate those by this thin washer. This washer was the one that came with the motor anyway. That was in here in the first place. So I'm going to slide that down. So now we're going through. So we've got the two motors together now. So we have the shaft turning here, and this is now turning independently of the shaft from the rear motor. I've gone ahead and clamped this down to the table, so we can do an initial throttle up now to full power, and then I'll ease the throttle back. So let's give it a try. Well, it looks like it is working okay. I just hope that those of you that have messaged me about how I've gone ahead and constructed this are happy with what you've seen, and maybe give you some insight on how to design your own. I'll have a link here to show an application of this working in my dual copter that I recently built. Thanks for watching.